Good morning and welcome to everybody to our second technical webinar. Today's webinar will be about the LCB. Last week we presented our new product LCB, the load cell digitizer. And today my colleague Matteo Grisanti, the R&D manager, will present you technically this new product. I'm Stefano Corradi from the Laumas Sales Department. Just few rules. During the presentation, your microphone and your camera, webcam, will be switched off in order to do not disturb the presentation. The only way to be in contact with us will be with the chat on your left of your video. You can make questions during also the presentation, and we will answer to them at the end. Because this presentation will be about 40-45 minutes, and then we will have a quarter minute or 20 minutes of question and answer. During the presentation, you will see some videos. We kindly ask you to do not push play or pause in order to be all together at the same time. And also another thing is the presentation will be recorded, and so it will be available on our website within 7 days, 10 days on the webinar page of our website. Thank you again for attending it, and if you have any problem during the presentation with the video, audio, or stuff like that, please write an email to webinar@laumas.it. Now I give the word to my colleague Matteo Grisanti.
Hello, as already told by Stefano, my name is Matteo Grisanti. I'm the Laumas R&D manager, and today in this webinar I will talk about the Laumas last product, the LCB, or load cell digitalizer, with the help of this presentation and of a couple of live demo. Here the outline of this webinar. So after an introduction about the instrument, we will see how to manage the connection of the instrument to the load cell, and then, supposing to have completed correctly the assembly composed by the instrument and the load cell itself, we will see how to configure it, and eventually we will see how to properly set up the remote management of this system on a Profinet I/O network. About the introduction, I start showing to you an introductory video about the LCB. We realized for efficiently show the main features of the instrument and the main concepts that guided its design. So let's play this video.
LCB series was conceived with an eye on IoT in view of the digital transformation, according to the Industry 4.0. Based on this approach, sensors must be able to exchange and communicate as much information as possible in order to keep plants and machines under control, improving their efficiency and productivity. The LCB digitizer can also be used on existing analog load cells with mini-volt, volt output, transforming the analog weighing system into a modern digital weighing system designed to implement the IoT Industry 4.0 functions. The assembly of the component takes place in such a way as to be completely joined with the load cell body. At the end of the installation, The system looks like a real digital cell with integrated field bus. It is compatible with any kind of load cell or strain gauge sensor already present on the market with standard quarter gas connection. On request, specific adapters are provided for coupling to the various threads of the cell. It is able to interface with any PLC model through appropriate waterproof connectors with input-output function. It has been designed to be typically applied in weighing stations that employ only one load cell. Thanks to the new IP67 waterproof box made of IEESY 316 stainless steel, LCB is suitable to be installed in any industrial environment, even aggressive. Micro USB port for an easy configuration of the digitizer via PC software. It is free from the action of potential electrical and electromagnetic interferences. It allows the free installation of the cell cable without particular requirements, eliminating any problem due to the distance between the load cell and the PLC acquisition system. Two digital inputs. Three outputs controlled by PLC via field bus.
Okay, now we can go on. Here in this slide, I reported a technical design of the LCB with some items specifically numbered and the list of the descriptions about these items. I would like to use this scheme for a couple of notes about the LCB hardware configuration. The first note is about the main interface of the instrument, composed by the three M12 connectors. The central connectors, here indicated by the number 2 and with the label service, allows to properly manage the instrument power supply and the digital inputs and digital outputs available on the instrument. Specifically, on LCB instrument, we have available 2 digital inputs and 3 digital outputs, all configurable about the function they realize. Again, we have also the bus in and bus out M12 connectors, here indicated by the number 1 and with the labels bus in, bus out. They allow to properly manage the connection of the LCB communication interface to the field bus I have to use in our application. The available or managed field buses with the LCB instrument are reported on the right side of this slide, where you are able to see their symbols. A couple of advantages offered by the dual port structure we chose for the LCB communication interface. First of all, this kind of structure allows to correctly install the instrument in ring or daisy chain topologies, and strictly related to this first advantage, exploiting this dual port interface, you will be able to avoid the use of Ethernet switches in case of Ethernet-based field buses. That has to be proved to give some issues sometimes in real application, at least from our technical support point of view. Another note about the instrument hardware configuration is related to the two M4 holes on the back of the instrument enclosure, here indicated by the number 7. They could be exploited in order to realize the wall mounting previously introduced in the introductory video. This is an alternative mounting configuration, respects the main mounting configuration we suggest. So the configuration where the instrument is directly connected to the load cell. Another couple of notes about the instrument functioning. LCB offers two different programs, a base program and a batching program. About base program, the instrument will behave as a normal weight transmitter, with this program you will be able to exploit the digital inputs and digital outputs in your application. About the batching program, here in this instrument we choose to implement the load program, one of the available batching programs on our instruments. And here in this slide I reported also some application examples. Namely, here we see a material test machine, a weight line check, and a filling machines. The first two are suitable for our base program, while the filling machines obviously is suitable for the batching program. In all these applications, we will suggest to use the LCB manager in case of a single load cell application. Well, now we can talk a little about the main mounting configuration we studied for the LCB, where we supposed to directly assemble the instrument on the load cell, creating a unique weighing system with a complete digital interface. To better explain this kind of mounting, I propose to you a video tutorial I realized and that is available on our website that shows the suggested procedure in order to correctly assemble the instrument directly on a load cell. So let's play the video.
Hello, in this video I will give you some suggestions about how to direct connect an LCB instruments and a load cell.
Okay, well, once the assembly composed by the LCB instrument and the load cell is correctly realized, we can go on to the next step of an hypothetical procedure needed to realize a real weighing application. This phase is the configuration phase. In order to configure a LCB instrument, we can choose among a couple of options. Namely, we can configure it using our LCB Manager PC software via the connection to the USB service port available on the instrument, or we can exploit the main communication interface in order to configure the instrument maybe before the start of the remote management. A specific note about this second option: in the case of the RS485 communication interface, you have to use the Modbus RTU protocol in order to correctly manage both the configuration and the remote management of the instrument. In order to better explain this phase, I will make a short demonstration. The setup of this demo is composed by a PC where I already properly installed the LCB Manager, and then I have a simple weighing system composed by the LCB instrument and by a Laumas ACN15 platform that in this case it will act as the weight receptor. The summary of the demonstration: substantially we will see the features of the LCB Manager, and then we will exploit them in order to correctly calibrate our weighing system, and eventually, once the calibration is satisfying, we will store the instrument configuration on a file directly on the PC, exploiting one of the serving functions offered by the LCB Manager. Before starting the demonstration, a brief introduction about the graphical user interface of the LCB Manager. Here I reported a screenshot of the application, highlighting its main sections with red rectangles numbered specifically, and we can see them. First of all, the rectangles 1, 2, and 3, all of them compose the instrument interface. As you can see, the display, LED, and keyboard section compose an instrument interface very similar to the standard interface adopted on all our instruments. This choice has been made in order to give to our customer a simpler approach to the use of this software. Then, in the rectangle number 4, we find the instrument information section. Once the instrument is properly connected to the software, in this section some information about the instrument will be displayed, as the firmware revision, the hardware revision of the instrument, the kind of program set on the instrument, and the revision of the set of parameters used by the instrument in its functioning. Then we have the communication section in the rectangle number 5, used to properly connect our instrument to the LCB Manager software. And eventually we have the section number 6 in the bottom of the graphical user interface, where you find all the serving functions offered by the software, namely Here we have the memory backup function that allows to properly save the configuration of the instrument directly on a file on the PC in order to be used as a backup copy. For example, in a successive moment, we could exploit it to realize an identical copy of a previously configured instrument in terms of parameters. Again, we have here the firmware update function, the reset to factory function used to make a reset default of the instrument, and in order to set some main options as the program base or batching to be set directly on the instrument. And then we have the settings function that allows the user to set a couple of characteristics of this interface, namely the language and the graphical scheme. For the language, in the last version of the software, we have available English and Italian as supported languages. So now we can start the demonstration, but now I have to switch from this presentation to my desktop in order to share it with you, where I already launched our LCB Manager application. The operation should take a few seconds to be completed. Okay, well, you should currently see the LCB Manager interface. Now I can connect using a standard micro USB cable that is here. I can connect the instrument to the PC. Okay. Now I have to wait a few seconds needed for the PC to correctly install the USB interface driver, and after a few seconds we can try to launch the search function of the LCB Manager, clicking on this button. With this function, the software will look for available instruments connected to the PC. As you can see, our instrument has been correctly recognized by the software, and this box has already been filled with the serial port associated to the instrument and with the name of the instrument. So we can go to connect to our LCB. After the connection, if successfully completed, as you can see, the instrument interface section is continually updated with the data retrieved by the instrument, and the information section is currently filled with the main information retrieved during the startup phase of the communication by the instrument itself. Now, we can exploit the keyboard of our interface to surf into the instrument menu in order to properly configure it. So, first of all, we can go into the menu, and to correctly make a calibration, we select the calib section, go in, and as the first phase, we can set the full scale of our weighing system. In this case, the full scale of the demonstration system is 15 kilograms. So we can type 15 kilograms in this edit box, send the value to the instrument, and press the interface enter key in order to set the value into the instrument parameter. Well, now we can go on. Sensibility is not important in this case because our load cell is a 2 millivolt per volt already set. But we can, for example, set the division not to 2 grams, but to a value of 5 grams. We can confirm pressing enter. For example, in this case, we are not interested in setting a maximum value, we can go directly to the first calibration operation, namely the zero operation. So we can confirm. Here we see the currently weight value calculated by the instrument, and pressing the Enter key, this value will be zeroed, or better, stored as the zero value of our weighing scale. Okay, now we can go back to the weight visualization in order to make a first check about the precision of our system. I will put now a sample weight of 5 kilograms as value directly on my scale, and as you can see, I probably choose a bad scale. We obtain a poor performance in terms of weight calculation, but in this case we can correct this imprecision exploiting the sample weight step of the calibration. So we can re-enter into the instrument menu. Again, we enter into the calib, go with the arrow keys to the weight item, we click Enter. Now we can type the correct value without the decimal point, so I have to type 5000, send it to the instrument and press Enter in order to be applied. Okay, we can click again, and the sample weight calibration is completed. Now we can go back again to the weight visualization and make a final check about the precision of our system. Now during this operation we see the calib item only, but using the instrument interface you are able, as I already told, to surf among all the menu sections offered by the instrument menu. So for example, we can set the filter of our instrument, and so on. Okay, now supposing to have completed our calibration, we can exploit the memory backup function in order to properly store the instrument configuration on a file as a backup copy. This function offers the possibility to save different set of parameters. Namely, we can save all the instrument memory content in terms of parameter, or we can choose to save only the param section related to the base functioning parameters, or again, specifically for the batching program, we can choose to save in a separate file the batching formulas once they have been correctly set on the instrument, or again the batch data, so the parameters needed to properly configure the specific functions offered by our instrument in the case of the batch program. In this case, because the instrument is set as a base instrument, we can go to save the param set. So we can select it and click Download Memory to File. Now we are able to properly set the name of our file. So then we can click on Save. The data will be retrieved and put into the file that now is available on our PC. And once completed this operation, we can again reconnect the software to the instrument for other configuration phases. Okay, with this operation we can consider concluded the configuration phase of our instrument. Now we can switch back to the presentation. Okay. Once our weighing system is cabled and configured, we can think to have to properly install it in a more complex application, involving also some remote management of the system, exploiting a field bus interface. In order to give you some information about this phase, I will present to you a second demonstration. In this case, the setup is composed by our weighing system. In this case, the LCB chosen is the LCB Profinet IO model, and we will use in order to simulate the industrial application, a SIMATIC S7 1200 PLC of Siemens and the TIA Portal version 14 as a configurator software for the system. In this demonstration, we will see how to set up a simple TIA Portal project, how to import into it the LCB instrument, how to configure the parameters needed to obtain a correct communication on a Profinet network, and eventually we will see, once the communication is properly obtained, how the instrument interface is structured. Now, again, in order to proceed with the demonstration, I'll switch again to my desktop. We have to wait a few seconds. Okay, now you should be able to see my desktop, where I already opened an instance of TI Portal version 14. I already opened a simple project and put into it our PLC unit. Now we can go on looking for the LCB instrument in the catalog available on our TIA Portal installation. As you can see, the instrument is already present in the catalog because I previously correctly installed the GSDML file of the instrument. So we can go on. I put the instrument directly into the project. I can set the communication between the PLC and the instrument. Now I have to properly set up the two parameters needed for a correct communication on the Profinet network for the LCB, namely the IP address and the name that will be assigned to the instrument on the network. To do this, I go to the properties section. Here we have a proposed IP address of 192.8.0.1. For our network purposes, I change this address to 138, and as a demonstration purpose, I can change the assigned name to the instrument into demo LCB. Okay. Now, the parameters are properly set into the project, but in order to obtain a correct communication, we have to assign the correct name to the physical object. So we can exploit the assign device name function to our instrument. We can update the list. Okay, The software has successfully found the LCB instrument on the network. I select it, and now I can assign to it the correct name of demo LCB. Okay, the name has been correctly assigned to the instrument. Now we can go on compiling the project. Okay, and now once the project is correctly compiled, we can download it directly onto our hardware devices. Okay, we load the project onto the PLC. Okay, and to test the communication, we can go online. Okay, the green checks mean that the communication is correctly functioning on our hardware system. Now, we can see, exploiting this function of the IA portal, the exchange data between the PLC and the instrument. In this case, we see the data sent by the instrument to the PLC. Here, I previously built a simple table with each byte exchanged, named with a specific label. So here we can see the first 4 bytes that compose the gross weight value sent by the instrument on our PLC. Okay, at this point, with the system correctly working on the Profinet network, we can switch back again to the presentation. And with the last slide, I will introduce to you a couple of notes about the communication interface structure offered by the instrument on the field bus chosen. In particular, here I reported a couple of tables. The first one describes the data sent in our structure by the instrument to the PLC, from the instrument to the PLC. And in the second table, we find the input data, so the data sent by the PLC to the instrument. As you can see, for each area, I reported the fields composing it, and for each field, I indicated its size in terms of byte. The notes about this structure, first of all, this structure is always the same, independently by the field bus interface you have to use in your application. And this aspect could make or should make more simpler the instrument management from a programmer point of view. And again, the last note, this structure is always the same also, independently by the program set on the instrument. So this structure is the same for the base and the batching program. And using this structure of communication interface, you will be able to correctly manage both the configuration and the remote management of the instrument. So, with this last information, I concluded my presentation.
Okay, thank you, Matteo, for your presentation. We hope that the presentation has been clear. But anyway, we now have about 10-15 minutes for any kind of question or clarification that you need. So we just wait a few seconds for the first questions. Just want to remember you that at the end of the webinar, you will get an email from Laumas with some question about the webinar. So we kindly ask you to answer it and then send it back to us so we can improve our webinar and see what goes wrong and what was good. Also, this webinar will be available next week on our web page. Okay, we have the first question. Matteo, Mr. Schubert is asking, okay, you connect the LCB on the bus in or out or service? It's not really clear, the question, I think. So maybe just we wait. Let's clarifying the question. You can connect the at the Profinet demo. Okay.
Yes, okay. Actually, we used two of the available connectors in this case because we used the central connector, so the service connector for the power supply of the instrument, and then we exploited the bus-in connector for the Profinet I/O connection with the PLC. In the case of Profinet interface, you can use indifferently one of the two connectors, because in case of Profinet we have not a specific input and a specific output connectors.
Okay, thank you, Matteo. We just wait some more questions. Okay, Mr. Grevazzi is asking if can batching receipt be set by the software?
Yes, both using LCB manager or exploiting the main communication interface, you will be able to properly set the batching receipts and also all the parameters related to the batching.
Thank you, Matteo. Another question from Mr. Moss is asking if is it possible to connect LCB to 4 load cells in parallel?
Yes, obviously it is possible. In this case, you should change the mounting configuration, maybe exploiting the wall mounting configuration, and also using the support of a junction box in order to compose a system made by the 4 load cells connected all to the junction box, and then connect the junction box exit, analog exit, to the analog input of the LCB.
Okay, very good. Another question from Mr. Goivazzi. How many receipts can you save, and does it have more than one batching speed? So,
yeah, in current revision, you are able to save up to 99 batching receipts. Each receipt is composed by 2 weight thresholds, a preset threshold and a set threshold. So you are able, exploiting both the 2 threshold and the digital output, to compose a batching system able to properly manage 2 different batching speeds, in order to have a batching procedure with the first high-speed session up to the preset threshold, and then, in order to gain more precision, a slower session in the interval between the preset and the set threshold of our receipt.
okay, thank you. We have another question from Mr. Moss that is asking if we are planning to develop an LCB, ATEX or IECX approved version. I just want to remember before to give the word to Matteo that last week we made the commercial webinar about the LCB, and where we explained all this stuff regarding version available, field buses available. So just I suggest you to go there and on our website and see the commercial webinar. See, it's for you, Matteo.
Okay, about ATEX or IECEX, we are studying the directives in order to find the better configuration for the certification. So in the next month, will be able to propose an ATEX or IECEX version for the instrument.
Okay. We got other two questions. The first one is from Mr. Bears. If we have the peak function on our LCB, okay, also controlled via Profinet. And another question from Mr. Zagar is asking if you can clarify where we connect the power supply of our LCB.
Okay, about the first question, yes, there is a peak function implemented in the case of the base program, and it is completely configurable and manageable by remote. So exploiting our communication interface, you will be able to light on and light off this function whenever you need during the instrument functioning. And about the second question, the central connector or service connector is an 8-pin connector, and in our user manual there are all the information needed to which pins are needed for the power supply of the instrument.
Okay, thank you, Matteo. So yes, as Matteo told, it's on the central connector we call service. You have all the pins for the relay input and output, and also for the power supply. We got another question from Mr. Moss. He's asking if it is possible to use an LCB with an external battery.
Okay, the available range of power supply for the LCB is a broad range compressed between 12 and 24 volts. So I think that it is possible to use an external battery if the furnished DC voltage is in the admitted range.
Good, thank you again, Matteo. Okay, we have a few minutes. If there still are some questions, we can wait a little bit. Just we don't want to steal more time than we asked before. No more question. Okay. If everything has been clear, I thank you very much for attending our technical webinar and for giving us your time. So just remember to answer to the question that you will get within a few minutes, and so we can improve our webinar. And thank you very much again, and have a nice day. Bye.
Thank you again for your attention. Have a nice day. Bye.